Hello, my name is Manjot Singh. I'm an enterprise architect at MariaDB, and I wanted to talk to you about disaster recovery, and specifically, how can delayed replicas help with your disaster recovery strategy? Well, the first two things we want to look at are your RPO, which is your recovery point objective, or how much data can I lose? How much data can I lose? And this is basically how much data can you lose when you restore that backup? So will that backup lose some data? Do we have to use an old backup, say from yesterday? So if you take nightly backups and you have a failure at, say, noon, will you lose 12 hours of data? And then your recovery time objective. How long does it take to get back up? Does it take you 8 hours to restore that backup? Does it take, a few seconds? And this is all very relative to your strategies. If you don't know the answers to these, I suggest that you go evaluate. Because if you're only taking nightly backups, your RPO, in other words, how much data can you afford to lose, is 12 hours. Whether you like it or not. So definitely something to look at. So let's say you have your database here, right? You have a primary database, and you want to recover. So let's say you had a failure at 1 p.m. So 1 p.m. and you lost all your data. You need to bring it back up. So you may be like other companies, and you may have your data out there on the cloud, maybe with Iron Mountain. Let's draw a little cloud here. And how long does it take to copy it? Let's be generous, and let's say it's a 1-hour copy to copy it from the cloud back to your database. And then maybe you need to restore it, run some process. So it's maybe a 2-hour process. So that means it takes 2 hours. Your RTO is 2 hours to restore this database. And then again, if it's a nightly backup, you may have lost 12 hours with your RPO. So how can we reduce our RPO and our RTO at the same time? Because usually with standard backup processes, if you lower one, you raise the other. So for example, it may take you 8 hours to restore point-in-time recovery. A lot of times, if you have that nightly backup, maybe you've supplemented it with binary log backups. Well, playing back those binary logs takes time. And I have another video on how that works. So that could take you a full 8 hours. So that means you've lowered your RPO, so you're not losing any data, but you've lengthened your RTO. Or you may have, 1-day backups, so you've lost more data, but you can restore them very quickly because they're sitting locally on the database. So how do we reduce both of those at the same time? The answer is delayed replicas. And delayed replicas work like this. You'll have a replica, but you'll set the variable master delay on the delayed replica when you configure it. And that variable will basically say, how long should we have it? So let's say this one is a 24-hour delayed replica. You can add a 3-day delayed replica. And again, in this case, DR isn't disaster recovery, as is the topic of the video, but delayed replica. But it does assist in your DR. And maybe you have a 7-day for long term. And so why do I suggest these? Well, you may notice something within 24 hours. Let's say you have a bad developer. He's gone in, he dropped a table. And even the best developers can do this. You can look back at, for example, an AWS incident that happened a few years ago, or similar incidents at GitLab and other companies where they've dropped a table in production. If you don't catch it in 24 hours, this replica is pretty much useless. So that 3-day gives you the ability to say, hey, we had an issue on Friday, we didn't discover it till Monday. You can still use this guy. Or maybe you have a part of an app that's only used now and then. It's not used as frequently. That's where the 7-day comes in handy. So I usually recommend these. If you're not going to be able to put 3 delayed replicas, for example, because of expense, maybe a 12-day and a 12-hour and a 3-day, maybe a 48-hour only or a 24-hour only could work for you. But you do need to recognize that having more of them lowers your RTO, or how long does it take, and I'll show you why. So how does this work? So we had this 1 p.m. failure, right? What we can do is issue immediately the command stop slave on the 24-hour one. And the way it works actually is it still has all of the data. So it's pulled the binary logs from the primary and written it to its local relay logs. But what it hasn't done is applied it. So it's not applied to the database, but it has the logs. So we've issued stop slave. That means it stopped pulling everything and it stopped applying. So what we do, and that application process is basically what's delayed. And we say start slave until, and in this case, we'll say 12:59. And again, this is slightly pseudocode, but we'll say 12:59 p.m. And that means play everything up to the point right before a failure. And again, with the binary log granularity, you can actually do it right until the transaction right before the drop table. And then you can actually do skip. So you can do a skip transaction. So you can skip the GTID or the bin log position for that specific transaction. That was the issue. And if you want, you can then again issue start slave. And that start slave will go back and start all the way up until now. So let's say it's like 5 p.m. now. It will actually do everything from after the drop until 5 p.m. Now you've lost no data. You have that table back. And up until this point, it was maybe at the most a few minutes. It depends on how many writes you have, how large your binary logs are. But it's much faster than the old process or importing binary logs, especially if you have parallel replication enabled. And again, I have another video on parallel replication. But if you've issued the start slave, you're up to date. You can now take this guy and promote them to primary, and then just do a rotation of your topology. And you're up to date, you're back up, and this is much faster point-in-time recovery with delayed replicas than the old methods. So definitely recommend an investment into delayed replicas for those data failures and even for node failures, specifically looking at RPO and RTO. I hope this helps you out. Thank you.